Let's create a bandpass filter subVI and then test the filter's operation. The heart of this filter is the Butterworth filter available under the signal processing palette. I'm going to turn on context help to give a sense of what inputs we have to work with. See, quite a number. The main ones of interest though are filter type and order, the sampling frequency, and then the high and low cutoff frequencies, as well as the signal input and signal output. So we will be using most of these. And it's always a good idea when you're using a built-in subVI for the first time to take a look at its help page. In particular, I wanted to check the sampling frequency. It says we need frequency in hertz. That's important to know because some subVIs use frequency in hertz, others use normalized frequency. You just need to make sure you know which one to use. Let me begin by creating a constant, and this can then be adjusted to the appropriate filter type, and then I'm also creating a constant for the filter order. I want a bandpass filter, and let's just give this a little bit more steep response, and we'll go with a 10th order filter. Now I previously created a global variable to give me access to the sampling frequency. You could just as easily use a control or a constant for this purpose. This global variable also indicates the maximum frequency of the signal of interest, and that's what I can use to establish the upper and lower frequencies for my bandpass filter. Let me create a numerical control for the center frequency. I'll call that FC, and this has the units of hertz. Now these need to be combined in such a way that we can drive these two inputs of the Butterworth filter. I can take my center frequency, add the maximum frequency, and that establishes my high cutoff frequency. Take my center frequency and subtract that maximum frequency of the signal, and that establishes my low cutoff frequency. All right, we're doing pretty well. Now we can start to work on the input signal and the output signal. Let me create an array for the input. I'll begin by placing the generic array container. Let's change those names to in and out. And then I can apply a numeric control, just simply drop that in, and a numeric indicator. And we've now got those available in the block diagram. I'll connect that up to X, and then I'll temporarily connect this to the output of the filter, but I do need to make some additional modifications. In particular, I would like to use a Boolean control to selectively enable or disable this filter. I'll call the Boolean control enable. I'll tick it so it's turned on. While I'm at it, let me go ahead and establish a default value for the center frequency, and then save that away using make current values defaults. Now the point here for the enable is to select either the filtered signal or simply select a pass-through for the input to the output. We can do that under the comparison palette using this select device. You can really think about this as a 2-to-1 multiplexer. So we operate this with the enable. When the enable is true, we want to use our filtered signal. Let me drop that down so it's not crowding the words quite so much. And then when the enable signal is false, we would like to select the input and bypass the Butterworth filter. All right, let's go ahead and establish the icon for this bandpass filter. I'm just going to do a very simple one, BPF for bandpass filter. I could adjust the size of the font. You can also adjust its position. And if you'd like, you could change the color. There's all sorts of things you can do about laying out the graphics for your icon. I'm just going to do something very simple for this demonstration. Then as far as the pattern is concerned, let's go ahead and use this version right here. This allows me to connect my center frequency on the bottom, my enable on the top, and the signal output in the center, and the signal input also on the center. Give this a label on the front panel, call that bandpass filter. Select the text, hit Control-0 to bring up the font style dialog, and let's just make this a little bit bigger. We'll use 24 point. I will then go ahead and save this subVI away. Let's call that bpf.vi. Now at this point I want to create a new VI that would serve as my top level calling VI for the subVI that I've just created. So I select a VI, place the bandpass filter. I'm also going to select some other VIs that I have handy. This is a triangle wave signal generator, and this one is a signal viewer. Let's go ahead and align these on the bottom edge. Then interconnect the signal paths. And I'm going to right click and create a constant for that enable. And then also create constants for the bandpass filter center frequency and then the oscillation frequency of my triangle wave. I'm going to create the indicators from my viewer. And this allows me to see the spectrum and the time domain viewpoints of the signal at the same time. Let me begin with the filter disabled. Here we see the spectrum of the triangle wave. Let's try a different frequency. Higher frequency makes the spectral components more widely spaced. Now the bandpass filter is engaged and we see that it selects only 2 of those spectral components. I'm going to rerun this for a moment and then turn off auto scaling. Now we can clearly see how we've just picked off these 2 components. That wraps it up for this subVI.